So yeah, doing this myself itself, let's try to do it. And if there is anyone who will help me out, please help me uh, at any point, right? So if anyone wants to help me, can help me out here. Hmm? So I hope my voice is clear. So yeah, anyone is solving this question, uh, I hope can help me out. So we are intensities connected by some number of flights. Okay, you are given an array flights where kind of file. Okay, from to say this is a flight is from where city I. Okay, you are given this through source, destination, and yeah, okay. That means cheapest price from the source to destination with the most key stops, with utmost key stops. So, what does it mean? It means this is an important point is you are given with utmost key points the cheapest price from these both are different things, right? Okay, the cheapest price from the thing. Okay, and the format of this QoS is this one. Okay. Return cheapest price from source to destination with a key stops. And there is no such route return minus one. Okay. We are given cost, so we could consider. Uh, I think this is a disturbance. Yeah. I could consider these things as a cost, right? So when we are traveling, if we want to find the shortest path, okay, it is generally need to memorize, like we need to figure out it's the shortest path thing. So the cheapest price means think it as a cost over a graph, then it will be seeming to be the short cheapest price. Okay. Now on above it, we are given with condition we need at most k stops, right? It should not exceed this thing. Okay. Minimum number of stops. That like which are less than k. That is thing necessary. Okay, so let's consider this one. So how do I find a solution on it? Think I hope yeah, this one was good. Okay, now I'm given that the source is 0 and the destination is 3 to reach and key is 1. So do at most one thing or nothing, right? If you are at the same destination source of this. Okay, so we are just able to go from 0 to 1 once and 1 to 3, right? Okay, what are these? We could have only at most 3 stops, right? So since there is a no path, should be minus how come above the given path, then one half response between 0 to 3 is marked in red. It's a constant. Okay, so it means that like yeah, one thing I have figured out is that different like these colors, like these things represent me that hey, there is a route from 0 to 3. So there is no stop with no stop at 1. But it says that yeah, of course it passes through that path. Okay. And other than the blue part, it says that yeah, we could reach from 1 to 2 or 1 to 3 or 1 to 0 directly by passing through the node 4. Okay. Okay. Now the thing is, how do we need to figure out that color part on here? Okay, we are going from 0 to 100, 0 to 2. Let's say the thing. We are given 0 to 100. Okay. Then 1 to 2. And if you go to 0, 1 to 3. Okay. Hmm. But I could say, yeah, there is a stop like at 1. So only one stop, right? We should not consider how many these are there. Those are obviously two, but we have stopped at one, right? So in that way, we could think. And one more thing is that about the cost, uh, we have got that as I think because C, there is a small, of course, there is a other smaller part which exists when we okay try to travel from 0 to 1. 1 to 2 and 2 to 3. It's just costs me around 400, right? But thing is, there are two stops. Remember, we are going from here. We are making a stop at a node. So what are the how many intermediate nodes you would be visiting? That would be said as stops, right? Okay. This is the condition basically it is given to you so that you would uh, try to stop observing those paths, right? In a DSA algorithm now. So now, how do you do this thing? So if you could try to observe, this is exactly the similar problem to that of the latest weekly LeetCode contest of question 3. So when I try to upsolve this, I came to know it is also similar. But still, I'm trying to find out, and yeah, of course, it is similar. Now, let's try to do the things. Hmm. So, one thing is that we need to do a dice algorithm over here. So, let's do it as base over here, right? So, so at this point, let's focus on the diagram only. So, how the diagram is implemented. So, basically, we use a priority queue in order to keep a track of the smallest cost at the top and use it repetitively. So, it's a greedy algorithm which tries to first explore using the smallest first and then move on with it others. So let's build it. Uh, so do I need any other thing like other than node? Yeah, of course. Distance, right? Distance and node itself. So what I would do is, um, what about making a class? Okay. Um, I have to say it as let's say has I would say the thing as a cost. Yeah. Yeah. For this node here, let's say that right. So okay, now what we will do is we will try to uh, need it to get sorted based on the cost, right? So I will put the comparator over here. I think it's made about okay, uh, this this cost and the cost. Hmm. Okay, so do I have any other things? One thing is maintaining the like cost array itself for the each node. So how much will it cost for that thing? So what I'm gonna maintain a cost. Uh, so let's cost for short cost. Let's say and let's since we have nodes, so okay. Okay. Now since we are starting from the source itself, it would be like dot offer there. So we are starting new. So no more. Okay, the first thing we need is a cost. So what I will do, yeah, starting from there itself, it would be from which node it's a source, right? Yeah. And the next thing is short cost for that particular array or source. Right, we are initially starting from the yeah. Once we are done with this thing, I think we can write a safe template of if okay. Now let's try to follow the current one. Before was it's something similar thing itself. The thing is, I haven't built that adjacency list. So yeah, let's try to build it. So what does it require? There is a data load as well as that cost, right? So when I would try to pull out here this and I want to ask adjacency list, it would give me those nodes along with their cost, how much distance are there. So how could I do? I could easily do if consider this as node, okay? and I'm storing them as a sum, the node and the cost itself, right? So this is the cost and this is the node and maintaining a list of this thing. So let's a list since the initializations are done as uh, 0 to n minus 1, right? I think if I am not wrong. The first list would be for the indexing, and the second list would be helpful for storing those things. Okay. Now, there's one stone. So going there for this one. So what is needed? Number of nodes as well as the branch. Okay. Let's say that there is sort of cost for comfortable manufacturing. Let's initialize the each list inside the SW. This so for that, what I will do is run from is equals to 0 to I less than 10 and after the since we use we do have at least an empty list, right? So we got right. Now, once this is completed, I need to build that thing. Building that edges, right? Okay, this is so which edges. What I would try to do is I would try to access it first thing. Then try to add what I need to add. I need to add both the node and the cost. So I will use this class. Uh, carefully see here. Thing explain center. First index would be from. So H is a pretty like array of 2 and 3. So 0. The second thing would be the from 2. So it's not this one. It's edge of this and the need or price. We could say anything. This once know that cost is there, then afterwards it's the contract. Yes, once this has been written, so simple. Okay. So we have an access for it. Now, what I would try to do is, I would get a node, right? I would get a node. Hmm. Let's say I use the windows. Um, efficiency dot right. So since I am looping it, we would get a node, right? Okay. Should we call like this? No. Uh, let's say this standard now. And then the name is start and price is equals to or cost, whatever is uh, the cost. I would also say it as cost itself. Maintain on same thing. currently. Um, okay. Now I have been doing perfectly. What should I do is I have seen this one or we should ask some questions to it. Whether we should update or is this cost? So what I would try to do is okay. So since we are dealing with the cost, I would say is we extra minimum we would enjoy definitely. So RS not fail definitely right. So short cost we get the max underscore value. Okay. Now the shortest one has given it to 0. Okay, right. Everything is set. Now I will ask whether my current distance or sorry, my current cost is it far lesser than the what I assumed. So how do I do? So what is the current cost that current node has? So it's basically current cost plus how much it takes to travel from that current node to here. So basically that data comes from this neighbor itself, right? Because I'm calling the current node. So if I say um, node that would be neighbor dot node dot cost, right? So neighbor it becomes something like neighbor cost. Okay. If this is less than that what we have said, uh, cost of this neighbor node, right? Then I need to change that. What I should do? I'll try to update the thing. Some people might ask why I'm doing it if why not use method next since I also need to update the queue at the exact same point. I need to do like this. Okay. Instead, let's say this as it's the correct say uh, post right very fast and including this is becomes like okay. Now since it is done, what I should do, I have updated the thing and the cost is being less. What I would have to put it into the okay and now observe from this perspective and see if this is the smallest cost, then I will try to explore from here. Okay, since I have updated this one. So what I should do now, first I need to write the distance, sorry, cost. So that would be, we could write the temp cost of it. And all that is never know. Okay, that's good. Mhm. So this is how the things work for the diagram. Like otherwise tries to write it down. So at last we reported since we have visualized with this if it is not possible, we need to write a minus one. As you remember, um, there is this set a small group, right? Much optimizations are not huge. So pricing this as line. Okay, this will be not what I put is in the return, but I say that uh, this this destination destination, then it will be it is uh, onto this. So we are safe to go ahead with printing written messages. I think it's fast track. Hmm. That's simple minus. Okay, so this is one. That is the normal part. Now we need to add a thing called as this. So regarding this construct, right? This is our construct. At most case of itself, it should not have. So if we want to travel in those spots, we need to discover. So in general, what is the mistake? What I have done is I just kept a small if else thing which tries to stop this thing, like following that part. Okay. But the major thing that I would be facing in the future is let me show it with an example. Um, for example, it is said that K should be somewhat okay, like 5. Now, let's say since you are going node by node, okay, uh, of course, in the larger graphs, more this thing would occur to you because I have seen this thing. What happens is when you go from some source node to the destination node, okay, this is the destination, this is the source node. Uh, there might be different paths, right? With maybe there is a path from with maybe there is no need to there is a direct path itself. So there is k equal to 0. So consider like this thing k and might be this is the cost, right? Now consider this thing. Okay, consider this thing. Right. So we are having k as initially 0. Right? Uh, Okay. Let's say we are having initially k as 0. Then the cost is somewhere, let's say some 23, right? Then 1, which is uh, sorry, 70, right? And at 2, it is saying that the cost is 10. Let's give this smaller thing. Okay, let's keep the k is equal to 3. Uh, it says somewhere 24. Uh, the 3 says, let's say maybe 19. Okay, and my 4 say maybe 9. Okay, and maybe so on, right? Now the thing is, if you're saying that, um, like, if I put just a small condition, if else condition saying that when you are entering into this and you are finding the k, okay, the k is higher, then you need to reject this thing, right? So how do you actually see here? Actually, at that point, what I have did is, in order to track this k, uh, I just manually wrote, like, like manually just maintained one more pointer over here, like one more value, which is what is the key for it. And when I try to access over it here, like this for loop, I see the key is higher than this, like that's number of steps or number of stops, you could say, is higher, then I would try to stop it. But the major flaw somewhere I have pointed is that we need to memorize, right? We need to memorize, uh, we need to memorize those things. For example, let's say this is a set for, let's say, okay, this is for a set for a middle node, right? This is for the middle node, okay? Okay, this is for the middle node. Now, while reaching from here to here, there is a different story. Let's, okay, let it be here. Now, what this becomes as, maybe it's 25. Maybe if I consider this one, it now has become 30, maybe, right? Uh, now, we, we can ignore this part, right? Like, these are not considered with that following thing. My aim is to tell you that by just keeping that condition would uh, try to solve this problem. For example, um, say that it two and maybe somewhere for so okay, leave this thing. The main is that at this point you have seen that the cost is being somewhere 23, 17, and this is being the smallest, right? Although, yeah, of course, this one would be rejected, right? This one would be rejected if I simply put the condition. But the main thing is, we are trying to just take, by simply maintaining a single cost, we're trying to just maintain minimum thing. But after that, it is really being, we don't know if that path is going to that destination really leading towards an optimal path. Maybe this is higher at this level, but by reaching the destination, it is the smallest path. Okay, maybe see, like this is the 25. So we also need to consider the key part, and this is the whole story comes here. Now the whole point is we need to, let's, like, I could write it over you here. Um, Let's say seven steps, or sorry, stops, stops, right? And we start stops, right? Mm. Okay. What I would recommend is at this point, I will ask um, what are my current steps, or I would say, hmm, one thing is that hmm, I remember that one thing. What seems my current cost is below than more. But in any case, it's an invalid so short list so of cost of that I don't know to ignore, right? So I would say continue that. Okay. The next thing is it is the national is and to be done that thing. Distance. So I will know kind of prompts. That's it. But if I see, right? If here I will see current stocks, sorry, current stocks is being currently, I see that put it here or here. Hmm, what the main focus of it? Right. When you try to assign it, you need to check it out, right? Whether uh, it is good to assign or continue with the other thing. So let's start about the thing over here. So current and it wants to convert. Here, over here, same. At this point, what would be the thing? Okay, now somehow we don't even know. Okay, so when I try to move, right, try to move, moving is right. So considering one node, yeah, of course, but there is a thing like good considering. this one. So, okay, like this. Okay, we go step. Reach the one step. We're not taking this one. Something. Um, remember that wrong one, since you know the current shocks and that you know that minimum what your current carrying, okay, by for that path itself. But the thing is, right, when current starts to exceed, yeah, when current stops exceed, should I need to put them into the queue? Should I process them? This is a good question. The thing is, hmm, let's say if my like, uh, cost is much more greater, right? So the number of stops, correct? Stops. What I have is when if it is there, not equal to two, hmm, okay, it depends on the current view. It's not about the, but also when our game is number of rows excluding those start and destination, right? If you put it here, we will try to count that thing. So we will try to put it here, right? It will only consider at this point. It will not consider at this point. Hmm. So that then have a bit of confusion. Let's try to do here. So if the current stops, right, is still greater, so we could try one more bit. So if I try to put it here, what happens is, if I want to try one more node, okay, and if it is equal to Q, I could still try, right? Because it will proceed it. If I put it here, it will be proceeding to the next one, and if anything is, that would be dropped off. The thing is, it will consider that as extra time, so not the present one. I need to count the present one. Okay. So when I reach the neighbor, I will see neighbor. So these are the neighbor stocks that will have at the stop. Because initially the stock starts zero and reaching it here. I would say one is increment. Okay. Let's do this connection as well. I do update. So normal minimum cost. I need to update it with current stocks plus here now no stock has been added. The thing is the one has been like one stock has been added. I will do on DFS of this. I will put this into the queue. Okay. You could say this would be something like with price is zero and this node is source and this one is okay. Now there is a middle node. Uh, so what would be the what is the cost? Some yeah, I would say cost one. This is the node one, right? Number stops and will become 100. Okay, number stops and will become 100. Now what about destination? Now it's the destination point. So now if I see, okay, if this FSK is equals to 0, now before going further for this, I need to stop it over here. Okay, if k is set to be as, let's say, 0, then I should check it over here and would say uh, until, right? Or else what I will do, I will go current less one, right? Right. Here it becomes 2 or not it becomes possible, right? Okay. So this is about the stops. Simple different. Is it good to write this particular like this condition over here? Current stops, right? This was the last stops. This setting the let's take it over here. Why not there? Hmm. It's already fulfilled over here, right? It would be so while moving your BFS, starting a doing a BFS, the current stop would say how many stops are there in the past. For example, here it would be 0, it will be 1. So I think that would be wise and okay, the condition over here, it makes more sense. Um, right? Look at the constants. So then please then you will then but for now let's say that's the thing. But do you actually see that do you actually take other path? Is it really possible? The thing why I'm writing continuous because in the queue we might having other nodes, so we want crossing with this. We can't stop that loop here itself. Okay, so we are skipping that path. That's it. So on the parts, something that could be actually rejected. So yeah, this is actually what we would try to attempt. Let's see first how many issues are there. Yeah, of course, there are some issues. Okay, I understand that. Initially, yeah, it is being somewhere. What are the steps for that? Number of steps. So it's we don't have anything assigned. Let's minus. Is it a problem over here? I think it's not a problem because they are actually with the queue and I'm just trying to use this one. Mhm. Started to zero and this is the point where we are starting. What I don't see. In something like um, people find the price tag. So the price, the rich, and then last ones. Yeah. So, mm, okay, I'm doing the mistake. Any help? Say nobody. Seeing, I think it's seeing the paths or what? Is it seeing the paths? Because if you see the paths, then it is actually counting it, if I'm not wrong. Okay, okay, I understand the thing. Maybe it's counting the paths and returning them as an answer. So it should not be that the case. That's what I'm saying. What is the level? So we have first by pulling out. Let's start with this one itself. Alright. Um, I would try to store the something even. Try to store something like 0, 0, 0, and 0, right? I will try to do only one part example. I will go here and I will try to say, okay, in the preface, I will try to put this into the queue. And I would say the first thing would be the price, cost, it would be 100. Then actually putting the cost here. Since the initial cost was 0 and your neighbor cost you have seen it as 100, right? Okay. Okay. We would be adding your current cost that is 0 and first and it becomes 100 and your motivation. So how would you work and your steps will be what 0. Right? Yes, you have lots. Let's take the first part. Right. Let's take this part. Right. It shows that now the cost has become 200. Before that, it says, hey, my k is equal to 1, right? So for this example, the k is given as 1. So if it goes here, uh, it will belong to, right? So considering it would be not a good thing. So what I will do a plus thing over here and see here. So when I reach it here, right, and try to, okay, that was my. So when I reach over here, I would say I should try to reach the now the destination itself. Should not go further. Mm-hmm. So what I would try to do is because logic and continue with that thing. About one type I think. Okay. Still there is a point. This is image option then at present. and it's the destination becomes right. So if I try to do this one, automatically it will be removed. Okay, because so if I even okay, I will go inside it, it becomes 200, uh, and the node becomes 2, and the thing becomes 2 steps. But the thing is, when it tries to click before and try to unplug because it's not the destination, we know the number of steps are going to so we try to remove this one, exploring this one. When you try to explore this one, remember, uh, since it's a destination, it would be directly returning it, right? This would become 700 and 1 and sorry, 3 and some also for video. Okay, so this is the case of harvesting. But the number of states would still be one because for the destination it would not be updated, which is perfectly fine. And that's it. It will be returned at that point itself. So that's why I have stopped moving. Oh, this is the major return stops. First, let's try to run see. Accept it, but there is a there will be a flaw. Let's try to I will try to explain. I have seen that the commands, right? This is an interesting the so it is known as 0, 02, that's 7. Okay, 0, this is 7. Now it's positive 1. Now 0 to 2, its cost is 5. Its cost is known as 5. 1 to 2, 1, and the 2 to 3 is known as 1. Okay. So if I talk about the is there is only one stoppage, so this one should be recommended. Answer would be 6. Okay. What I think is going with minus 1, right? So some not a good error, but I could show you the real answer. Then what could be the thing? Okay. Initially, this will be thing. The cost will become just I will try to write the cost steps over here. The cost would be 0 and not 0. And step 0, right? Now at this point, the things will become like the cost as well as 1 and the steps as well as 1. At this point, cost will be 2 and steps will be 2. So by reaching here, yeah, of course, this part would say, so it would be a reject easy because what it does is it says to. So when I try to do it, it would be rejected over here itself, right? So this will be rejected. Now it says this path, right? Okay. So now the thing is, it is not storing this one because why? Now, if you carefully observe under the constraint, we have faced the same example. This till this node, right? Till this node, like this one over here. This is looking as an optimal path, and still the key is under the answer itself. So it is considering and keeping this one, even though our BFS tries to do with this. It says this cost is 5. We already have some least cost, but we don't know what is that K, right? How many steps it will take us. So we need to take the number of steps also into consideration over here. So let's say it has taken the steps. So plus bounds. You see that there. Let's say number of steps. Steps. Okay. Now I just going to try to optimize it. So for which step? I mean which stop? Mm, First try to ask for this one, right? What you are having. Then have another thing to go here. There is, I mean, first it will be first step as well. So next step. Okay. We're going so so what I would say is um, first 2200, right? The thing is transferring to the minimum one. Okay, you can't say which step. Okay, there might be multiple steps where you need to take the minimum over there. Yeah? So I would try to say try to take the minimum. Um, you pause. Going back, which is sorry, this thing smaller in this one. Um, so the value is smaller than the minimum steps because initially we were given as an example. So I need to pass on what it is. They are F1B and one, right? So there we have this. And let's say it's it's a 2D array, right? 2D array. From that 2D array, I want to attract only that last one, right? Actually, you could say, I just say that n minus one, right? Only the last one itself. That's the main important. Somewhere that sort of think, think over there. So it's very bad. Very lot of bomb. Yeah, as a response is itself more than so he's saying something like, yeah, of course, sometimes shows itself for more than one thing. The thing is, it is responsible by traveling. So, after all those things, you're traveling from here to here, that's it. No stops. So, how do we say? When you go there, they're actually doing well and asking over here that, uh, okay, so, Yes. Uh, yeah. So, so I am that's also yeah. Yeah. Actually, this was progress. So that's not this is a way. So that's all.